Hey guys, it's Mrs. Neviker, and I have a question for you. Why don't mathematicians go to the beach? Any ideas? Maybe. Okay. Because they use sine and cosine to get tans. Ha ha ha. It's good, huh? Okay, that's my joke for you. The joke is because we are going to be talking about trig ratios. So remember, trig ratios are sine, cosine, and tangent. See? Get it? Okay, so sine, cosine, and tangent are abbreviated sin, cos, and tan because 3 letters on the calculator is pretty much all you can get. Then we also need to remember about Sohcahtoa. So it's Sohcahtoa. Okay, and remember the S, the C, and the T all stand for the S, the C, and the T in the trig ratio, so you know which one you're using. And these, the O and the H and the A, those are all parts of the triangle. Remember, these are our fractions, our trig ratios. So it's really S equals O over H, C equals A over H, and T equals O over A. Okay? So again, O is for opposite, in case you forgot. A is for adjacent, and H is for hypotenuse. Okay, and those are parts of a triangle, and they are parts of a right triangle. And they have to be a right triangle, or else it doesn't work. Oh, sorry, my bad. Should slide that up. Okay. The adjacent and the opposite depend on where you stand on the right triangle, but the hypotenuse is always right across from the right angle. If we draw a cute little tail, it always points to H. It's really important that you label that first and then kind of go from there. All right, so there's a little bit of a review for you about the trig ratios, and now we're going to do a problem. Okay, so what you're going to be given is some sort of a right triangle. So here's my cute little right triangle. And you're going to be given the side lengths, so like 30, 60, 90. And then you're going to be you're going to be given letters that stand for the angles. So, for example, A, B, C. Then what we're going to do is we're going to ask you a question. So our question could be, what is the sine of A? So you're going to have to write the trig ratio to represent the sine of A. So remember, sine stands for opposite over hypotenuse. So we're going to make a fraction that is our opposite measurement over our hypotenuse measurement. Remember, it's always good to start with labeling your H because the H never changes, but the A and the O do, and sometimes it's really confusing. So label your H first and then kind of go from there. So sine of A, that means that we're standing over here where the A is, and we want the sine. So we want the opposite of this point of the triangle, and we want to put that number of the side length over our hypotenuse. So we're putting it over 90, because 90 is our hypotenuse. And then the opposite is 60, because it's not touching. Adjacent sides have to be touching where you're standing. But this side is not touching you, so that is our opposite. The next thing that you need to do is you need to type this in your calculator and reduce your fraction. I mean, you can reduce it other ways. I'm just going to show you with reducing it in the fraction. These cute little fractions will do it for you, which is super fancy. Anyways, so 60 over 90 reduces to 2/3, which most of you knew already, and if you didn't, that's cool too. So your answer for this problem would be 2/3 because we just want the ratio. Let's say we use the same triangle, but instead of sine, let's say we wanted the cosine of C. Okay, so cosine, or ka, is adjacent over hypotenuse. So when we write our ratio, we want our adjacent side over our hypotenuse side. Well, hypotenuse side is always 90. We just have to figure out what's adjacent when we stand at the point C. So we're going to stand over here now. We moved, not there. Okay, we're smaller. It's further away, I guess. I don't know. Anyways, we want the adjacent, not the hypotenuse. So if we're standing here, we want the side touching us. Well, this side touching us is our hypotenuse, which is why it's really good to label that first. This other side touching us is our adjacent side. So that means that this number goes on top, which actually ends up being the same trig ratio, which is totally cool. Let's say that we wanted to do sine at C. Sine at C. So remember, sine is so... Okay, so we want the opposite over the hypotenuse. So we're still standing here. We look so pretty. Oh, yeah. Ooh, let's put shoes on. Oh, yeah. Shoes. Okay, then we want to put the opposite side, so not the adjacent side. This time we want the opposite side, which is 30. And we want our hypotenuse, which is 90. Again, we can reduce that in our calculator, and we would get 1/3. And that is our trig ratio for sine of C at using this triangle for that calculation. Okay, so let me or Mr. Anderson know if you guys have any questions. We're happy to hear from you. We miss you very much and hope you had fun. Tell all your friends the joke. Okay, bye guys.